Today we're going to talk about tsunamis. We're going to build off of what we've already learned about earthquakes and talk about this phenomenon that is most commonly generated by earthquakes, this coastal phenomenon of these giant waves. Um, Japan is home to almost 1/3 of all of our known tsunamis. And so we have a lot of tradition. The term tsunami is a Japanese term. We first interjected this into English over, about 120 years or so ago, a little more than 120 years. The term tsunami is Japanese for harbor wave. Um, it can obviously happen in areas outside of harbors, but nevertheless, harbors are a place where we are very often have seen this phenomenon. We sometimes use the not particularly accurate term tidal wave. And so tidal wave isn't exactly correct. This is sort of a nitpicky thing, but tsunamis aren't related to tides at all. So while in your head, some people, when they hear tidal wave, they think tsunami. The reality is, by and large, most tsunamis are not impacted by tides, and they're occurring separate from the mechanisms that generate tides, our routine day-to-day tides. There's a huge amount of fact versus fiction with tsunamis. They're very iconic, and they're used in all kinds of disaster movies and things of that nature. So, for example, in the lower image here, you see a still from the disaster movie San Andreas, where a supposed 250-foot wave was going to come in and destroy San Francisco. And so you see these big, massive waves that are either destroying the Statue of Liberty or the Golden Gate Bridge, or something, the London Eye or some Singapore high rise or something of that nature. The reality is up north. So this is from the 2011 Japanese tsunami that had propagated across the Pacific and struck San Francisco Bay. And this is Emeryville next to Oakland. So this is inside the bay looking towards the city of San Francisco. And here you see the actual tsunami wave, which is much more typical of the types of tsunami waves that we get. And this was only about a 1-foot high wave as compared to the 250-foot high wave in the Hollywood version. We have a lot of sources, just like many other things like earthquakes and volcanoes and things of that nature. We have a lot of sources of information in terms of our beginning to get our heads or our arms wrapped around tsunamis, what they were, how frequently they are, etc. And they've really worked their way into a lot of different cultures. So one example of this are the stories, the traditions of the Native Americans on the west coast of the U.S., and in particular, folks, for example, around Northern California that tend to get more tsunamis than, or perceive more tsunamis than many other regions. And so if we look at these areas, for example, over here on the right, we see some different areas where Native peoples have stories about things that relate to earthquakes and tsunamis. Over here on the left, we see researcher Alfred Krober talking with a guy named Robert Spott, who was a Native American who helped translate some of these early stories and get them into more of the technical literature, more of the Western traditional academic literature, and a really great collaboration and valuation of traditional ecological knowledge, traditional heritage, etc., and how that helped move us forward in our understanding. So one example of this is again, you can go and you can map out where we have different Native peoples' stories about various elements of geomorphology related to earthquakes and tsunamis. And you can map that out and then overlay the two and then compare the two. And so, for example, here's a story from the early 1900s about some events around Crescent City in Northern California. And here, the story goes, as reiterated, these folks were standing on rocks above the river mouth, and a native person felt the ground move suddenly, and then the trees swayed, and then some of the trees fell over, and then the shaking just seemed to go on and on. When the earth shakes, this gentleman's dad had told him, look at your canoe. If it's sinking, get up on the reefs and run for high ground. And so his canoe was sinking. So along with the water level, he ran. So the canoe was sinking, the water level was sinking. He got out of there, and he got away from the water, and pretty soon the water came in, and eventually it left behind it a trail of death. How we would interpret that in terms of our modern understanding of earthquakes and tsunamis, we would say this first passage maps very accurately to the experiencing an earthquake, obviously. The next part may have to do with liquefaction and the shaking of the ground. The next part, though, talks about water receding or drawback or drawdown. And so this is consistent with some aspect of tsunamis, not necessarily the very first wave, but certainly with subsequent waves. And then the water floods in and inundates the land, and we have a big tsunami wave. So we can learn a lot from all kinds of sources. The oldest sort of detailed discussion about tsunamis in Western literature is from Thucydides' History of the Peloponnesian War. And in this, he talks about, I won't read the whole thing. You can pause the video here and read this. But basically, earthquakes are happening. And at this one particular area at the coast, this huge wave comes in and nukes the town and just puts the town underwater. And as he says, so that what was once land is now sea, such the inhabitants perishing as could not run up to the higher ground in time. And then notes other patterns, right? So noticing this is not just a one-off, but a similar inundation occurred at Atalanta in this other coastal area. And it carried away part of a fort and messed up some ships which were on the beach. And the sea retreated a little, etc. And so then later on, Thucydides says the cause, in my opinion, of this big wave of water was most likely the earthquake. So I think so. This is him tying this one particular disaster to the causative driver being earthquakes. Japan, which is again, the birthplace of so much of our understanding of tsunamis and our thinking about tsunamis and our understanding of impacts, etc. This is essentially history of the empire, big volume, and this particular this particular edition basically was compiled in 1901. Or excuse me, in 901, excuse me, not 1901, 901. And so there's several examples in this, but just two quick ones were in 869, it reads, sometime after severe seismic shock, so after an earthquake, a gigantic tsunami wave reached the coast and invaded the entire Sendai plain. Rising seawater flooded an old castle town, causing the loss of 1,000 lives. There's also indications from earlier. So on a stone marker near a different coastal city, that marker read, always be prepared for unexpected tsunamis. Choose life over your possessions and valuables. If an earthquake comes, beware of tsunamis. High dwellings are the peace and harmony of our descendants. Remember the calamity of the great tsunamis. Do not build any homes below this point. So this marker was essentially a warning symbol and a public safety tool and a memory device to try to make sure that people did not forget the lessons paid so dearly by their fellow citizens. Japan also gives us some of the classic images of tsunamis, and this is perhaps one of the most classic images of Japanese art in general, at least in the Western world, as we recollect Japanese art. And this is a woodblock print from 1831, and this is often represented as a tidal wave. Technically, this isn't really how most tidal waves necessarily look, but again, the idea is trying to visually comport the idea of this big ominous wave, and it's coming in. These fishermen are in these boats, and it's this huge wave towering over the mountain, etc. So this notion of very powerful sea, very powerful surging inland of ocean water, is very much so associated with many of the historic and unfortunately current experiences of the Japanese people. Another example here before we get going into the specifics of tsunamis. This is a 1896 earthquake in Japan. And this was a pretty big quake, a magnitude 8.5, off the east coast of Japan, which is the east coast is also where we're going to have our 2011 tsunami, but more on that later. So huge. Hugely impactful earthquake here, killed at least 22,000 people, destroyed at least 9,000 homes, and the tsunami was the second highest recorded in Japan. So that's in meters. So almost 40-meter tall wall of water coming ashore, hugely devastating, hugely problematic. So that tsunami was so powerful, it gets written up in National Geographic, and so a story comes out a couple months later with the first pictures of tsunami that a lot of the folks in the Western world have seen, and importantly, uses the term tsunami. So this is the first time in the Western world that we have the word tsunami, and then it begins to catch on after here. So now we use the tsunami word to describe this phenomenon all around the world. Another example here of fairly common types of tsunamis, particularly in the Alaska area, and these are landslide tsunamis. So in this case, we had an earthquake, 7.8 earthquake, and that earthquake induced a rock slide of a huge amount of rock. So about a little over 30 million cubic meters of rock fell almost 1,000 meters down this escarpment and boom, plowed into the shallow waters of this embayment in Alaska. And the depth of the water here was only about 32 meters, so it was relatively shallow water, as you'd expect in a fjord type situation like this. But this huge rock fell, a huge mass of rock fell super fast. Boom! It smacks the water, and it generates the highest known tsunami wave that we've ever officially documented. So the height of the wave was at its peak was 524 meters, right? That's almost 2,000 feet high. That is massive. So on this map here, this is from the USGS, and unfortunately this is in feet, not meters. But so this is how high. So rock slide here, the red area is where the event started, where the tsunami began, where the earthquake loosen the rock, and then this is the epicenter of the tsunami. It propagates down through this area, and all the yellow area, such as right here in this picture on the lower right, you see, represents areas damaged, denuded, trees stripped bare, or just completely removed from the landscape by this massive wall of water. Huge. So it's huge wave, and it pretty rapidly decays. So by the time we get a mile or so out, it's only about 90 feet. So it's only about 30 meters or so at this point. And then by the time we get out to the mouth of the embayment, it's only about 10 meters. So still huge damage, right? Even 10 meters is huge, but a pretty fast decay rate in this particular case in Alaska in 1954. And this is a very well studied phenomenon because there were USGS researchers nearby, and within 24 hours they were on site making detailed measurements and taking photographs, such as the photograph down here on the right. Now, whenever we talk about tsunamis, you're going to hear, hey, don't go check it out. I did not take that advice, and so when I was in grad school, we got wind of this tsunami happening on the other side of the Pacific, and we realized, oh my God, there's a tsunami coming. Let's go check it out. And so even though everybody was saying, hey, don't go down to the beach, we, as a silly young person, we went down to the beach. So we couldn't. We were worried it was supposed to come in any minute, and so we didn't go all the way down to the beach. We jetted over to Pacific Palisades from UCLA, and we were looking and looking, and we were expecting, again, raised on disaster movies and stuff. I was expecting a big giant tidal wave to come in and destroy the Santa Monica Pier and the Santa Monica Beach and everything. The reality is, when it showed up, and this was about 14 hours of crossing the global ocean to us from Indonesia. This was about just after noon, about 1 o'clock on this February afternoon, and we're looking, and we just keep looking. Okay, any minute, man, any minute, man, any minute. We're listening to the radio, and while we had good estimates, as we'll talk about later, we have much better estimates now in terms of timing, arrival rate, potential inundation from tsunamis, etc. But at the time, we're like, what's going on? What's going on? And so we kept, we're sitting there waiting, and a minute goes by, and 2 minutes goes by. My van was still running. Everybody jumped out of my van, and we didn't even really park it. We just got out on the road, and we're looking, and nothing happened. And 5 minutes goes by, and 10 minutes goes by, and so then I kind of officially parked the van, and nothing happens, and 15 minutes goes by, and so we waited for about an hour, and then we finally head home. And so there was a tsunami. We did, quote unquote, see it, but we didn't know we saw it, because when it arrived here, it was only about 5 centimeters high, and that's typical. Most of the tsunamis that we experience that come into our harbors and coasts are very small, and oftentimes difficult, if not impossible, to distinguish from regular wind or regular tides or regular, going up and down of the surface of the ocean near the coast. So again, most of our tsunamis are very small. They're not like the Hollywood blockbuster stuff. A few other notable tsunamis before we get into talking about the mechanics of tsunamis themselves, etc. Just a few examples here, running from the 1700s to our two most important recent tsunamis. They vary, right? So you can have a look at the earthquakes that generated them. They're typically at least about 6.5 in terms of magnitude quakes, but the bigger the quakes are, the more likely we are to get a significant tsunami. And you can see, again, the maximum heights here vary. Most of the maximum heights are nowhere near this large typically, but these are relatively notable tsunamis, so they're relatively big, and so they've caused more impacts, more costly damage, more loss of life, etc. And yeah, so I'd say this gives you a smattering of some of the more famous tsunamis. The most important ones recently, though, again, are going to be the Boxing Day tsunami in Indonesia, and the 2011 Japanese tsunami that was the one that led to the destruction and meltdown of the Fukushima Daiichi power plant in northern Japan. We can look at, we can use all kinds of sources. As we mentioned, we can use traditional knowledge, cultural stories, etc. We can also use all kinds of wonderful modern geology. In this case, we're looking at the 2004 earthquake off of northern Sumatra, the Indonesian tsunami. And we can actually see here the green is area where some of the sediments, some of the rock has shifted. The sediments have moved and displaced down This is a bathymetry, so this is underwater. Has displaced down, and that we believe was one of the factors that caused the generation of the tsunami in this case in 2004. Let's take a look at a couple of these videos here. Now, these are freaky, crazy videos, and so just we're not going to watch all of them, but these are deadly events, and lots of people unfortunately died in both in these next couple videos. So I just want to again show you to make sure you're understanding the power of these events. So in this case, we're looking at some compilation video, some raw video of these folks near the epicenter in Banda Aceh in Indonesia, and yeah, it's difficult to watch a lot of these disaster events as they're playing out, particularly when we know that a lot of these people are going to become victims. But so we have the earthquake first of all. Not a lot of warning, not a lot of public education, not a lot of communication to people of the hazards, and this is what resulted very quickly after the earthquake happened. So huge amounts of water pushing quite far inland, and not a lot of robust architecture to resist this inland movement of water. And with the water, everything comes: cars, trucks, boats, all kinds of structures, and things similar to a hurricane, in the sense that things that are regular everyday objects start to become incredibly dangerous and very problematic and deadly in their own right. So again, this is in a sense similar to our storm surge from hurricanes, in the sense that it's not a slosh in, slosh out. Oftentimes, there's so much force behind these waves that the water comes in and keeps coming for some time. You see this guy actually walking over debris. This is a shot looking seaward, and so these folks are here, and they're walking in an area where the sea has retreated. So super dangerous. So the water here is basically going out to sea, and there's a big roiling wave out there, and it's getting ready to come in. And so this is not the kind of place you want to be hanging out. You want to be running away as fast as possible. If you were ever at the beach and you saw suddenly the water retreat away from the beach and drop down, you want to get inland and get high as fast as possible. And now the water is rushing back in. So this area that was abandoned and people thought was a interesting phenomenon. Now it's coming in, and it's coming in, and it's coming in, and it just keeps coming. Okay, we'll watch another few seconds of this, and then we'll switch to another video. Just again, as with so many of our disasters, earthquakes, volcanoes, the incredible power here. It's very difficult to comprehend how much energy and force are being brought to bear. Okay, our next video is from the 2011 Japanese earthquake and tsunami. Actually, we'll listen to it with the sound just very low, I suppose. So okay, so here we're sitting here. So obviously the tsunami's already begun at this point, and we're getting a sense of how much power here. We have these large fishing boats, and we're going to see these fishing boats start to get whacked and push up against these different pilings. And so again, where these boats are, it is in an area that is exposed to seawater, but Japan, majority of Japanese coastlines, particularly in areas like this, are armored and protected with seawalls for this exact because of this exact fear. And so you see these boats coming in. The water has raised up high, and so the area just um, outside of the seawall, oceanward, waterward of the seawall, those areas are being inundated. So there's, you can't really tell, but there's a road down there. There's a place where the boats are docked up. Some boats are already flipped over, etc. And these boats now, which are large fishing, well, various boats, but especially fishing vessels here, are just getting hammered, and they're being pulverized because they're being thrown so fast into these bridge pilings and other structures. And so we're just going to see these boats be trashed and destroyed here, unfortunately. Okay, so now the people who are doing the folks that are recording this are looking at this and they're saying, "Oh my God, this is horrible. This is just really bad, and it's so sad, and all the destruction. This is horrible." They don't yet understand what's still coming. So another phenomenon we'll talk about shortly is the idea of the first wave, the second waves, etc. And oftentimes it's going to depend on if we're close to the epicenter, the source of the tsunami, or if we're far away. But oftentimes we're going to see that the very first wave isn't necessarily the most destructive. And so these guys are looking at this and they're thinking this is like a disaster movie, and oh my God, I can't believe this, and this is crazy, and this is just so sad what's happening. Most people don't understand. Most people think that this seawall is going to protect them. So you see this guy riding on his bike, and they're checking it out, and then someone starts to say, "Hey, there's something going on towards the mouth of the bay." And so they start pointing in a second, like, well, check that out. And the camera's going to swing over here, and they're like, "What's going on? It looks like the water is still going higher." And so now the water is raising up, and it's now going over that seawall. And so you're going to start to see the cars go over the wall. You're going to see these boats go over the wall, and the city begin to flood. So now the boats are overtopping the seawall. The vehicles are going over the seawall. And now these people are starting to realize that, hey, maybe we're in danger. Even though we're up on this tall building, maybe this building isn't safe. So these vehicles in the parking lot are beginning to be destroyed and washed away. Boats are now starting to rocket inland. Right? So again, you see all these people driving that they don't realize the danger. They think that the safety structures are going to hold. They don't understand how vulnerable they are. And now this boat is going to go over the seawall. This doesn't, even having watched this many times, it doesn't seem real. This seems like some kind of special effects. It's super cliche. Everybody says it, but it's hard to believe this is actually happening. This was real video, actual events. Again, the water level goes up and it stays up. So there's a huge, huge force behind this water that's shoving it inland, moving it inland. And I don't know about this particular location, but some of the areas, it's going to depend on local geography and topography, etc. But some of the water got as high as a 12-story building. So this is just crazy. Again, if you're ever in one of these areas, You want to go inland as fast as you can get on a vehicle, on your feet, whatever, and get high. Get high and get inland. Do not take pictures. Get away, get away, get away. Okay, we don't need to watch more of this. You guys get the idea of the incredible power and force that these tsunamis are. Okay, so we'll talk a little bit about tsunamis in general now. So there's various factors that can actually cause a tsunami. Having said that, the vast majority of the time, the vast majority of the instigator is going to be an earthquake, either an undersea earthquake or an earthquake right next to the edge of the ocean. So something like way more than 70% of all the tsunamis that we've observed come from earthquakes, and primarily subsurface, subtidal earthquakes. Having said that, there's a variety of factors that can cause a tsunami. So we have atmospheric forces, things like squalls or derechos, the big sort of storm line of storms that we get in desert areas and things that we classically think of in places like the American Southwest or in the Saudi Arabia regions. Volcanic sources are huge. We can get them from pyroclastic flows hitting an embayment. We can get them from the volcanic explosion itself, from caldera collapse, etc. We can get a tsunami from nuclear explosions, either below the seawater line or atmospheric detonations. We can also get, as we saw from the Alaska example, we can also get tsunamis from landslides, both landslides below water as well as landslides next to an embayment or cliffside, something of that nature. We can also get tsunamis from calving glaciers. We can also get tsunamis from asteroids striking the Earth, but those are relatively uncommon initiators. So again, all these things can cause tsunamis, but most of the time we're talking about a subsurface earthquake under an ocean basin. Okay, so when we talk about tsunamis, what do we mean here? First, we have the quote-unquote regular tsunamis, or what we just call tsunamis, and versus mega tsunamis, and these would be very large event things. The mega tsunamis are these big giant events, oftentimes caused by something like a Krakatoa or something like an asteroid striking the Yucatan Peninsula, something of that nature. So that's not there isn't a hard and fast definition of what's a mega tsunami versus a tsunami. Basically, it's just a way for people to talk about larger scale events versus more typical events. Generally speaking, tsunamis are rare. A lot of conditions have to line up for us to get the right recipe to have tsunamis happening, propagating, occurring. So a large tsunami is going to, in the real story, we mentioned that 1/3 of all known tsunamis have happened in Japan, on or near Japan, or in or near Japan. And if we widen our gaze out a little bit larger, the Pacific Basin is really the story where most of these events are happening globally. So you can get tsunamis anywhere in the world, but it's really, again, the tectonically active, the volcanically active, the ring of fire active area surrounding the Pacific Ocean that is generating so many of the conditions that can lead to the generation of a tsunami. So we classically think of tsunamis as happening in and around Japan, but also surprisingly so, at least to me when I started reading up on this, the Eastern Mediterranean also is an area that has historically had tsunamis. Generally not quite as big as the stuff that we've seen in the Pacific, but nevertheless, the Mediterranean has its share of tsunamis. And this is a breakdown since 1900 of tsunamis. So again, 70% are in the Pacific, about 15% are in the Mediterranean. There's about a little less than 10% that are in the Caribbean or the Atlantic and Indian Ocean, and the rest are in other pockets around the world ocean. The impacts are, as I mentioned, with that 5 centimeter tsunami that struck in the coast of off the coast of Los Angeles. Most impacts are usually quite small. If there is any impact, it's typically in a harbor, some boats banging around that weren't tied up properly or something of that nature. In recorded history, we think that about 500,000 people have died over our history with tsunamis. The vast majority of that has occurred in our lifetimes since 2004, and that's because so many folks died in the Indonesian earthquake and tsunami in 2004. An unprecedented number, by far the most deadliest to humans tsunami known to have ever happened.